Given in this question is that there is a hot iron block of mass 25 kg. That means mass of a iron is given, that is 25 kg, at temperature 280 degrees centigrade. That means T1 of iron is given, that is 280 degrees centigrade. Then this hot iron block is dropped into water in an insulated tank, and that water had a mass 100 kg. So that means mass of a water is given, that is 100 kg at temperature 18 degrees centigrade. That means temperature T1 of water is given, that is 18 degree centigrade. Now assuming that the water vaporizes during the process, condenses back in the tank, then we have to find out the total entropy change during this process. Means our entropy total change we have to find out. So here's our solution start. First of all, we must know some terms: specific heat of water at 25 degrees centigrade is Cp is equals to 4.18 kilojoule per kg degree centigrade. And we must know the specific heat of iron at room temperature, that is Cp is equals to 0.45 kilojoule per kg degree centigrade, and these values we get from the table A3. Now we take the contents of the tank water, contents of the tank water plus iron block as the system. So this would be a closed system since no mass crosses the boundary during the system. So we use the energy balance for this system, which can be expressed as our energy in minus energy out is equals to the total change in energy of the system. So this becomes 0 is equals to del U, and this equals to, according to situation of our question, del U of iron plus del of U water, that equals to 0. Then this become MC T2 minus T1 of iron plus MC T2 minus T1 of water equals to 0. Now we're substituting the values in it that are given. So mass of iron, that is 25 kg, and C we find the specific heat of iron at room temperature, that is 0.45 kilojoule per kg into Kelvin. And then our temperature T1 is given, T2 is not given, so we have to find out T2. So T1, that is 280 degrees centigrade of iron. And plus m, the mass of a water, that is 100 kg, and c, the specific heat of water at 25 degrees centigrade, which we have get the value from the table, 4.18 kilojoule per kg into Kelvin. And T2 we don't know, and our T1 of water, that is 18 degrees centigrade. Now by solving this, we get the value of T2, that is 24.9 degrees centigrade. We have to convert it into Kelvin unit, so this equal to 297.9 Kelvin. Now the entropy generated during this process is determined from, first of all, we entropy generated of the iron, we get that equals to mc average ln of T2 over T1, and our entropy of the water, first of all we find their entropy is different separately, then we combine their answer to find out the entropy total of the process. So we put the value of mass m of the iron, that is 25 kg, given in the data, and the c value of the, means the specific heat of the iron, that is 0.45 kilojoule per kg into Kelvin, and ln of T2 we have find, that is 297.9 Kelvin by 553 Kelvin. So we um, convert our temperature degree centigrade into Kelvin. So by solving this equals to minus 6.961 kilojoule per Kelvin. Now we put the mass of the water, that is 100 kg, and the C value of water, that is 4.18 kilojoule per kg into Kelvin. Now ln of T2 we have find, that is 297.9 Kelvin divided by T1, as T1 is 18 degrees centigrade, so we converted that into Kelvin, 291 Kelvin this equals to. So by solving this equals to 9.749 kilojoule per Kelvin. Now we find out our entropy generated, that equals to our total entropy change, and that equals to the entropy change of iron plus the entropy change of the water. So we add on these two answers. So this equals to 2.79 kilojoule per Kelvin. So this is the required answer what we have to find, and this result can be improved somewhat by using specific heat at average temperature. So this is our discussion of the question. So this is our required answer. So thank you so much.